In this Back to Basics episode 2, I'm going to talk about REST APIs. You probably have seen APIs that look exactly like this, and they're also probably in production right now, being used by real customers or users and making money. It's working, nothing is broken. But do you see what's wrong with this? If we look at it closely, every endpoint is a verb, and every endpoint is something you need to remember. There's no pattern to guess from, and you might think that it's a good thing, right? It's for security purposes since no one can guess it. But no, that's not security. If you open the network tab in your browser and you can see every endpoint the app is calling, a URL nobody can guess is still wide open to anyone who looks. The thing that actually protects an endpoint is checking who's asking or who's requesting. And we will get to that when we talk about the status codes. Before we proceed, let's do a quick vocabulary check. An API is a defined way for one piece of software or machine to ask another for something, or it is a way for two computers or machines to talk to each other. And REST stands for Representational State Transfer. It's not a specification, nothing enforces it, and there's no compiler that checks if you're following it. It's just a set of rules people agreed on, and it's been the common way to build APIs ever since. And an API that follows those rules is what we call a RESTful API. You can see up here, the URL is a command, getProductId, and the verb post tells you nothing. Below it is the URL is a thing, a product, an order, a customer, it's a noun. And the HTTP method carries the action. Get to read it, post to create one, delete to remove it. And that's the core of REST. We call those things resources. And once you know the resources or the resource, you can guess the whole API. And that's actually the goal here. It's not about being elegant or showing elegance in the API. It's about guessability. Resources comes in two kinds: a collection, slash products, meaning all of them, and an item inside it, slash products, slash 42. That's one specific product. Same pattern for orders, same pattern for customers. And you can also nest them. When one thing genuinely belongs to another, for example, the item inside order 1001. And that makes sense. The items really do belong to that order. But this is where people go wrong. They just keep on nesting. And customers, orders, items, products, reviews, and now your URL is a whole paragraph. And every one of those IDs has to be valid or the whole thing breaks. Just remember this rule of thumb. Nest one level to show ownership. After that, use query parameter and just move on. Let's look at more examples of nesting because this is where most APIs go wrong. Here's the over nested version on the left. Customers, orders, items, product. Every single ID in that URL has to be valid or the whole request fails, and you're basically describing your database schema in the address bar. If you want product 88, just ask for product 88. It's a top level thing. The second row is the one that keeps the rule honest. One level of nesting is completely fine. Reviews belong to a product. So slash product slash 88 slash review is right. It's just one level. The third one, a customer's order is not ownership. It's a filter. So slash orders question mark customer ID equals 7. And the fourth one is one I see a lot. A status turned into a path segment. So slash orders slash pending. And that one has a real bug in it because now it collides with slash orders slash the ID. Your router can't tell whether pending is a status or an order number. Uh, Make status a filter slash order question mark status equals pending or completed, depending on what filters or what status you have. And the last one, stop at the resources you actually want. If you're after the author, the customer, or the user, just ask for the user. So follow the rule of thumb, nest one level to show ownership. Anything deeper than that, just use a query parameter. These five verbs should look familiar. I went through each one of them in details in the HTTP fundamentals episode. That's the first one in this series. If you haven't watched it yet, I'd start there because a few things in this video will make more sense. Now, watch what happens when we put the verb and the resource together. Get slash products, it lists them. Get slash product slash 42 is just that one product. Give me that exactly that one product with ID 42. Post slash orders, make me a new order. Put and patch, both change an existing one. And the difference between those two matters. And we'll go through it next. Last is delete cancels it. If I tell you we just added customers to this API, you already know the endpoint, or you can somehow guess the endpoints. We would have get slash customers, get slash customers slash ID, post customers, or post slash customers. So you get what I mean. You didn't have to see the full API specification, and that's what a good API feels like. Now, the thing I mentioned about put and patch, they look almost the same, but mixing them up can quietly destroy the data. Say your customer has a name, an email, a phone, and a tier, and you want to change just the email. Patch does that exactly for you. It changed the field you sent and leaves the rest alone. Put is different. Put means replace the whole thing with what I send. So if you put just the email in your payload, the server does what you ask. It replaces the whole entire record with an object that only has an email. So the name, phone, and all the other fields will be gone. And it's dangerous precisely because it still returns 200 OK. There's no error, no warning. The API did exactly what you told it to. So changing a fields, use patch. Using put, send the entire object every time. And on the server side, um, guard against it. If a put comes in with a missing field, reject it with 400 instead of silently wiping every record. And honestly, most put endpoints out there never hit this trap at all because they don't let you send a partial payload in the first place. The backend usually adds a required field validation for example, name, email, phone, tier. They're all required. So if you send a payload with just an email, the the put endpoint should return or reject it with the 400 because the rest of the fields are missing and they are all required. So even if you only want to change the email, you still have to send everything, and the server replaces the whole record with what you gave it, which is exactly what put is supposed to do. So the trap never fires, but the cost didn't disappear. You just move that onto the customer. To change one field, you now have to get the record first and change the one thing you want to change. Let's say, for example, in this case, we want to change only the email, but we still need to send the entire object back. And that read modify has its own problem. Imagine um, two people load the same customer. One user changes the phone, and other user changes the email, and both of them hit save. The second one obviously will win, and the first one or the first change is just gone, which the user one did like change the phone. So there will be no error, no warning, and that's the thing patch was meant to avoid. Delete has a choice hiding in it too. When you delete a customer, what actually happens to the data? A hard delete removes the row. It's gone from the database for good, and so is anything tied to it, like the past orders, unless you move those somewhere first or like archive them. A soft delete removes nothing. It's just a set of flag. For example, an is deleted column or deleted at timestamp, and that hides the row from your normal queries. The record is still there. You're just treating it as gone, doesn't exist. Most real apps lean on the soft delete because delete this customer almost never meant destroy everything. You still want their order history for maybe reporting or whatever reason. And you want to be able to also maybe undo mistakes. But soft delete has its own trap, and it's the exact opposite of put. Put loses data you meant to keep. So soft delete keeps the data you meant to lose because you're technically not deleting anything. You're just hiding it with a flag. The moment you forget to add the filter where is deleted is false to a query, the deleted record comes back. A deleted user shows up in a list, or a cancelled order still counts in a total summary report, and then you will have a broken data to show in your UI or a report. So hard delete is for when the data genuinely has to disappear. For example, a legal request to erase an account. Um, Remember, soft delete for almost everything else. As long as you just don't forget to add the filter on every query. Status codes are part of your API, the same way the URL and the method are. If you're creating something, return 201 and point a location header at the thing you just made. In .NET, I don't know, in other frameworks, maybe obviously they have the same thing, but in .NET, you don't even need to build that by hand. You return a created that action instead of just sending 200 okay or just okay. And the framework sends the 201 and the location for you. So you don't have to do anything else. If you delete something, return 204, just telling it that it worked. And there's nothing left to send back. No need to return any response object. And a 204 isn't only for deletes. It's also the right one to use for updates when the client already has the data. There's no point paying for a whole response body or to send the whole response body just to say that it's done or the request is complete. If they ask for something that doesn't exist, return 404. And if they ask for something that exists but isn't theirs, return 403. The server is saying, I know who you are, and the answer is still no. One caveat though, inside your own team, a plain 200 success is totally fine. You don't have to worry about sending 201 versus 204 and every single endpoint, as long as everyone within the team agrees what that 200 means. The 403 status code has a problem. A 403 tells the caller, this thing exists, you just can't have it. And sometimes that itself is the leak. A user might try to guess the user ID or order ID and see which one comes back 403 and which one comes back with 404. If hiding that thing, if hiding that thing it exists matters more, you're allowed to return 404, where a 403 should apply. For example, GitHub does this exactly. A private repo you can't see gives you 404, not a 403. So it tells you that this repo doesn't really exist. Instead of, yeah, this repo exists, but you don't have access to it. And both answers are correct. What isn't correct is just mixing them. For example, if your get carefully returns a 404 and your delete returns a 403, for example, you have get slash orders slash 1001, you sent a 404, that order does not exist. But then on the delete order, delete slash order slash 1001, you return 403. You see the inconsistency? Now you are saying it exists, but I'm not allowed to access it, or that user is not allowed to access it. So someone can tell the difference, and you've leaked the thing that you were trying to hide. So just pick one and use it on every endpoint. This next one is about returning 200 for everything. Say you return 200 even when it failed, and you bury the real outcome in the body or response body, and the API stops explaining itself. The client sees a 200 and assumes it worked. For example, your monitoring tool shows green, everything, every endpoint is healthy, while orders are quietly failing. And it's a genuinely headache or painful to work with. Every single caller has to unwrap the response body and check for an error field before it can trust the response. I've seen this a lot when I was just starting out, and honestly, I've done it too. So just remember that the status code is the contract. Don't bury the outcome or the result in the response body. Remember from the HTTP fundamentals episode that HTTP has amnesia. REST keeps that property on purpose, and it matters a lot because if the server remembers nothing between requests, then any server can answer any request. If we watch this interaction, I can run 3 copies of the store, the backend, send each request to a different copy or instance, and the client can't even tell that it's happening. That's how you scale from one machine to 100, and suddenly you can now cater to a lot of users or customers. If the server remembered your session, this would fall apart instantly. Now you might be asking, um, how do the requests get spread across copies or instances? That's a topic on its own. I'll try to get into it in the future. One practical thing every real API hits. At some point, you will need to change your response shape. And at the moment that you do, you will break everyone that's already using it. For example, you rename a field from name to product name, and every existing client that reads that name just broke. That's when versioning comes in. There are 2 common ways. You put it in the URL /v1 /v2 and so on. It's obvious and it's easy to route, or you put it in a header as part of every request, and it keeps your URLs clean. Both are totally fine as long as you plan for it instead of silently changing V1 while people are still using it. There's a model that grades how RESTful an API actually is. You have level 0, one endpoint, post everything. That's the API I showed you at the start of this video. The next one is level 1. You have resources, real nouns in your URLs. Level 2, you use the HTTP methods and the status codes properly, which are the 2 things we just spent this whole video on. And level 3, HTOAS, not sure if I pronounce it properly. Every response carries links telling the client what it can do next. So the client doesn't have to hard code URLs again. In practice, almost every API you've ever used, including everyone I've built, stops at level 2. I have never done any API that follows up until level 3. Or maybe I did. I just can't remember. Level 3 is the most elegant one, but you almost never see it. There isn't much tooling for it, and clients mostly ignore the links, and most teams, the effort doesn't just pay off. So when someone tells you APIs doesn't really rest, they're probably right technically, but stopping at level 2 is usually the correct call. The important thing is just know where you are on this ladder and that you decided or you choose to be there. Let's do a quick recap. URLs are nouns, methods are verbs, status codes are part of the design, every request standalone, and that's what let you scale. That's the HTTP has amnesia. And changing your response shape breaks people. And that's where versioning comes in. And that's the end of the REST episode. I'll see you on the next one.